Hello everyone! In this video, we will explain about Model 7, its sorting. Before we start, let us introduce ourselves. My name is Marsa Azwa Safrina. My assistant code is AWA.
I'm Syahida Asma Manina. My assistant code SYA.
I am Brightly Patmutomo and my assistant code is BIT.
My name is Sigede Premananjut Juviananda with my assistant code is GOT John.
Hope you enjoy, guys! Hello everyone! Back with me, the AWA assistant code who will explain the meaning of sorting. First, we need to know the purpose of sorting practicum. Number 1 is understand and comprehend the logic of sorting using the selection, insertion, and bubble methods. Number 2, able to implement the sorting logic into a program using C language. Now, let's move on to the basic theory of sorting. Sorting is an algorithm using to arrange a collection of data or arrays, such as number, characters, strings, and structs. There are two directions of strings. Number 1 is ascending, which means sorting from the smallest value to the largest value. For example, is 1, 2, 3, 4, and 5. While descending is the opposite, which means descending is sorting from the largest value to the smallest. For example, is 5, 4, 3, 2, and 1. But there are the several methods that can be used to sort data or sorting. There is selection sort, insertion sort, and bubble sort.
Hello guys, back with me GOT with assistant code GOT. So in this video I will give you explanation about selection sort. What is selection sort? Selection sort is a simple sorting algorithm that works by repeatedly searching for elements in a step-by-step manner. So, how the step-by-step of the selection sort? First, it finds the extreme value. It is maximum or minimum in an array and swaps the second index with the first index. Second, then it identifies the next extreme value and swaps it with the second index, subsequently isolating the second index. Third, the last, this process is repeated until the last data element. Maybe you guys after read or hear about that, maybe a little bit confusing, right? After this, I will give you a video that explain or give you a illustration how the selection works. A selection sort works. Okay, this is the illustration video to give you more understanding how to understand the selection sort it works. So in this video we have some datas like the numbers, and of course the numbers is not sorted by ascending like from the minimum value to maximum value. Now, how we sort it? Of course we use selection sort. Okay, the first step of selection sort is we found the extreme value. Because we want to sort it with ascending from the minimum to maximum, we have to find the extreme value, the minimum. So first step, we find the smallest numbers or the minimum value from 3 to 815. Of course the smallest is 1, so we get the extreme value or the minimum value is 1, and after that we can swap the 1 to 3 position, and yeah, the 1 is in correct position, right? The 1 is minimum value, so it got the first position. After that we isolate the 1 because the one is in correct position, so we can go to the next step. The next step is repeat the first step, like find the minimum value and swap it. Between 2, 8, 3 and 5, the smallest is 2, right? Nah, because the 2 is in correct position, so we just don't do anything, just let the 2 in its position because it's correct. So because the 2 in correct position, we isolate it. After that, we repeat again. We have to find the minimum or smallest value between 8, 3 and 5. Of course, 3 the smallest, and swap it to 8. After that, 3 is in correct position, so after that we can get to next step. The next step is repeat again until we find the smallest value again and swap it, and it will stop until the data is sorted. So in this video, the data is already sorted by selection sort, which 1, 2, 3, 5 each. And because the data is already sorted, so the selection sort is finished. Hello guys, back with me. In this video, I want to break down the C programs that contain the selection sort. Okay, in the first line, there is our library that we want to use, standard input output like usual, because we want to use function like printf and scanf. And next line, it contains the variable that we use like e, integer e and j to looping, and temp variable or temporary variable to swapping the numbers. Next, the min variable to hold the index for the selection sort. And next, the jumlah variable to store the total of data that we want to use. In the next line, we declare the integer array name of angka. It contains the 50 maximum of capacity. Okay, next. Okay, in these lines, we want to the user input the how many data that they want to store, and to input the numbers in that data. First, we prompt the user enter the number of data points they want to sort. We store this value on the jumlah variable. Then we use a for loop to let the user input each the number. The loop runs from e equal to 0 to e less than jumlah, filling the angka array with the user's data. This is for looping. This line is contain the selection sort algorithm in C. In this first line, we got the outer loop. This loop iterates from the first lines or first elements to the second to last element. The variable I represents the boundary between the sorted part of the array and the unsorted part. On each iteration, we're finding the smallest element from the unsorted part and placing it at the same position I. Finding the minimum element is at this part. Min equal to e, we assume the current element at index I is the smallest. We store its index in the min variable. We store e, I to min variable. Next, inner loop. This loop starts right after e and checks every remaining element in the array. In this if-else logic, this is if statement compares the current element in angka with index j with the one we currently believe is the smallest in angka with index mid. If the condition is true, it means we found a new minimum element. If it's not, we were not found yet. Now, here's a crucial point. The sweep operation is inside the inner if block. In this code, the swap happens every time a new minimum is found. Well, this code will still sort the array. It's less efficient because it performs more swaps than necessary. The standard selection sort algorithm should look like this. After the selection sort algorithm, we move to these lines. Finally, the program prints the sorted array. This loop simply iterates through the now sorted angka array from I is equal to 0 to I less than jumlah and prints each elements, showing the result of the sorting process.
Hello everyone, so here next we will learn about another sorting method, namely as insertion sort. So insertion sort is a method of sorting random numbers by comparing and inserting numbers into their appropriate positions. So we can imagine it as if we were arrange cards. You would take the cards one by one and then inserting them into their appropriate positions. To find out more, let's check simulation videos on how insertion sort work. Okay, here we already have random numbers that we will sort in ascending order from smallest to the largest. Okay, here we have 3, 2, 8, 1, and 5. Okay, in this method, in insertion sort, we will always start the sorting process from the second element. So here in the sequence of numbers, the second element is number 2. Okay, let's see here. We will take the number 2 and then we will comparing the number 2 with the number it's left. And then if the number we take is smaller than the number to its left, so it will move to the leftmost position, like this. So here for this example, the number 2 is smaller than the number 3. So the number 2 will move to the left position of number 3, like this. And then this process will repeat until the last element and until the element sorted. Let's check about the third element here, the number 8. We will take the number 8 and then we will comparing it with the number is left. Because of the number 8 is larger than the number is left, so the number 8 will just stay in its position, so there's no change, like this. Yep, and then we're gonna check for the fourth element here, number 1. Number 1 is smaller than the number it's left here, so the number 1 will move until the leftmost position, like this. Then it will repeat until the last element here, until it's sorted like this. Okay, Next here, we will learn about the code program of insertion sort in C language. Here, on the top, as usual, we have hashtag include stdio.h, and then in main, and also here the declaration of variable and array we need. And then here is the main process for the insertion sort. We have two looping process here, for and while loop. From the first loop process here, we will obtain the key. The key is the number that we will compare and insert it into the appropriate positions. Okay, here the J is the number to its left. So after we got a key, the number that we will compare and insert, we have the second process, the second loop process here with while loop. If all the according here are fulfilled, here are the requirement. From this second loop process, we will obtain a shifted number process. So if the requirement is fulfilled, the number that bigger than the number we take will move it to the right position here. So the J here, look at the symbol, is for bigger. When the J, the left number is bigger than 0 and bigger than the key, which is the key is the number that we will compare. So it will make it move to the right position. And then here, the syntax here, it means for the position change of the number. Okay, like this, and then let's see if we run it. Here, the number is already sorted in ascending order.
Alright, for the next method of sorting, we have bubble sort. Bubble sort is a process of sorting that compares initial data with the data subsequent to it. Now, what this means is if we have a data with the index of I, we're comparing data I with data I plus 1. Now, if we were doing an ascending sort, how this works is if we compare the data and we find that the current data is larger than the next one, it then swaps places. That makes the data from data I now become into index data I plus 1, and the element in data I plus 1 goes into data I. So it swaps places of the elements within the index, but the index stays the same. Now this process keeps repeating until all of the data is sorted according to our coding. Either it is ascending or descending. This is how it looks in a video demonstration. Now this swaps because the 2 was smaller than the 3, and then this swaps. Now, how this works after we find the largest number, the overall array, the sorting would just only sort for these 4 indexes now. Why? Because we have found the largest number of 8. We don't need to compare anything to it now because we know on the final index that is the largest number. So we're only wasting our time if we compare the largest index. So if we found the first iteration, in the first round, we find the largest number, we then decrease the size of the array for us to do the sorting method. Next, we do the second round. It swaps and swaps. Here we swap again. Now, here we find the second largest number. Now the array is only the size of 3 indexes. And then it swaps again. And then, it's okay. And then we found that all of it is completely sorted according to our needs. This is ascending. Now, if we look at the code for bubble sorting, we can find that here we loop from I n minus 1. Why is that? Because in an array, this is we've learned this previously. In the array, the index only goes from 0 until the size of the array minus 1. Now in our array, we have 7 elements, which means we have I plus I of 0, 1, 2, 3, 4, 5, and 6. There is no index of 7, even though we have 7 elements. Now, for j, this is how it works. We do j as our looping because if I is 0, then we go to up to j j5. Okay, why do we only go to j5? Because we only compare j5 with j6. Now if we're at j6 and we're trying to compare it with j7, right, if we're comparing it to j plus 1, then it would have no result because there is no j7. Okay, so if it's at I of 0, then we compare from j0 to j5. We compare j0 and j1, j1 and j2, j2 and j3, j4 and j5, and done. Now, once we finish this iteration, if we find any that compares to each other and we find, oh, it's bigger, then we do a swap. How we swap is we use a temporary temporary variable, and we keep one of the elements, we put it in temp, okay? And then now in array of j, now this is empty, right? So in array j, we put the array after it. So now the array after it is so the element after it is now in array of j. And then we put in the array of j that's now empty of j plus 1, we put the initial value of array j. That is how a swap is done. We do this for up to 4 times or 5 times because once we do I of 1, it only goes up to j4 and so on until we have a completely sorted array. If we run it, we can see before we sort the array, we can see that it is completely unsorted, like 64, 34, 25. But after we do the bubble sort, we can see that it is fully sorted. How we do a descending is simple. All we have to do is change this symbol. And now we can see that it is sorted descendingly from largest to smallest value. Thank you.
Thank you for watching and see you in laboratory room.